Queue.Queue versus collections.deque. I need a queue which multiple threads can put stuff into, and multiple threads may read from. Python has at least two queue classes, Queue.Queue and collections.deque, with the former seemingly using the latter internally. Both claim to be thread safe in the documentation. However, the Queue docs also state, collections.deque is an alternative implementation of unbounded queues with fast atomic, append and pop left operations that do not require locking. Which I guess I don't quite understand. Does this mean deque isn't fully thread safe after all? If it is, I may not fully understand the difference between the two classes. I can see that Queue adds blocking functionality. On the other hand, it loses some deque features like support for the in operator. Accessing the internal deque object directly is X in Queue. Deque. Thread safe. Also, why does Queue employ a mutex for its operations when deque is thread safe already?
Queue.Queue and collections.deque serve different purposes. Queue.Queue is intended for allowing different threads to communicate using queued messages/data, whereas collections.deque is simply intended as a data structure. That's why Queue.Queue has methods like put_nowait, get_nowait, and join, whereas collections.deque doesn't. Queue.Queue isn't intended to be used as a collection, which is why it lacks the likes of the in operator. It boils down to this: if you have multiple threads and you want them to be able to communicate without the need for locks, you're looking for Queue.Queue. If you just want a queue or a double-ended queue as a data structure, use collections.deque. Finally, accessing and manipulating the internal deque of a Queue.Queue is playing with fire. You really don't want to be doing that.
If all you're looking for is a thread-safe way to transfer objects between threads, then both would work, both for FIFO and LIFO. For FIFO, Queue.put and Queue.get are thread-safe. Deque.append and Deque.popleft are thread-safe. Note: other operations on deque might not be thread-safe. I'm not sure. Deque does not block on pop or pop left, so you can't base your consumer thread flow on blocking till a new item arrives. However, it seems that deque has a significant efficiency advantage. Here are some benchmark results in seconds using Python 2.7.3 for inserting and removing 100k items. Here's the benchmark code.
For information, there is a Python ticket referenced for deque thread safety. This URL. Title: clarify which deque methods are thread safe. Bottom line here, this URL. The deques append left, pop left, and lend operations are thread safe in Python. The append methods have a decref at the end, for cases where maxlen has been set, but this happens after all of the structure updates have been made and the invariants have been restored, so it is okay to treat these operations as atomic. Anyway, if you are not 100% sure and you prefer reliability over performance, just put a lock smile.
All single-element methods on deque are atomic and thread-safe. All other methods are thread-safe too. Things like len deque, deque4, yield momentary correct values. But think for example about deque.extend mylist, you don't get a guarantee that all elements in mylist are filed in a row when other threads also append elements on the same side, but that's usually not a requirement in inter-thread communication and for the question task. So a deque is 20x faster than Queue, which uses a deque under the hood, and unless you don't need the comfortable synchronization API, blocking, timeout, the strict max ISO bans or the override these methods, _put_get, to implement other Queue organizations' subclassing behavior, or when you take care of such things yourself, then a bare deque is a good and efficient deal for high-speed inter-thread communication. In fact, the heavy usage of an extra mutex and extra method ._get etc. method calls in Queue.Py is due to backwards compatibility constraints, passed over design and lack of care for providing an efficient solution for this important speed bottleneck issue in inter-thread communication. A list was used in older Python versions, but even list.append /.pop0 was and is atomic and thread safe.